Hayalperestlerin, risk alanların, denemekten korkmayanların cesaretinden doğduk. Bizi asla yarı yolda bırakmayan o sesin rehberliğiyle ilerlemeye ve öğrenmeye devam ediyoruz. Bunun için varız. Bu yüzden gece geç saatlere kadar lambalarımız sönmez. Elveda demek hem hüzün hem de gurur verir. Her şeyi sorgulayarak ve merakımızı besleyerek, dayanıklılığımızı test ederek, sınırlarımızı aşarak, ilerleyerek ve yeni ufuklar açarak yeni bir yol buluruz. Yeni icatlar çıkararak, kendi yolumuzu çizerek. Burası fikirlerin doğduğu ve yeni fikirleri doğurduğu, bizim de doğduğumuz, birlikte büyüdüğümüz ve yükseldiğimiz yer. Burası Yakın Doğu Üniversitesi.
Good morning. Hello, everybody. I would like to say welcome you all to our workshop, EnROADS workshop. Today, I am planning to talk about EnROADS in civil engineering. This presentation prepared by me and by dear colleague, Associate Prof. Dr. Yusuf Kasım. EnROADS, developed by Climate Interactive, MIT Management Sustainability Initiative. This is our content. I am planning to talk about EnROADS, climate change and civil engineering, EnROADS and civil engineering, and I am planning to complete my presentation together with conclusions. Let's start with EnROADS. EnROADS is a cutting-edge simulation model used to test climate solutions and generate climate scenarios for the future. EnROADS is an interactive climate solution simulator developed by Climate Initiatives and the MIT Sustainability Initiative. It helps users explore the potential impact of different climate policies and solutions on global temperature rise, greenhouse gas emissions, and other key climate metrics by 2100. With EnROADS, users can model the effects of policy changes in areas like energy sources, transportation, industry, land use, and carbon removal, allowing them to see how different strategies could work together to limit global warming. EnROADS is used by policymakers, educators, business leaders, and the public to explore what-if scenarios, promoting a deeper understanding of complex climate systems and the trade-offs associated with different strategies. It's known for being accessible, scientifically rigorous, and designed to foster dialogue about climate action. For more information about EnROADS and how it works, you can watch our former workshops. We organized 4 of them. And first workshop related with hybrid workshop on climate change and simulation of its scenarios using EnROADS tools. We started at 22nd November 2022. You can easily reach our links anytime. For more to learn how to practice EnROADS, you can watch our second workshop. It was related with from theory to practice, and it organized 10th May 2023. Additionally, if you want to learn more how to practice EnROADS on smart cities, you can also watch our third workshop. It was related with practice on smart city, and we organized it 3rd November 2023. The last one, fourth one, how to practice EnROADS for energy sector. You can also watch our workshop and you can reach our link. It was related transition to sustainable energy. The last one organized at 30 April 2024. This year we organized the last one. And let me start to talk about the climate change. Climate change refers to long-term shifts and alterations in temperature, precipitation, wind patterns, and other aspects of Earth's climate over extended periods, typically decades to millions of years. Currently, the term often describes recent and ongoing warming primarily caused by human activities, particularly the burning of fossil fuels, deforestation, and other processes that release greenhouse gases like carbon dioxide, methane, and nitrous oxide into the atmosphere. These greenhouse gases trap heat within Earth's atmosphere, creating a greenhouse effect that leads to global warming. These warming effects, weather patterns causing extreme events like intense storms, drought, heat waves, sea level rise, and shifts in ecosystems and biodiversity. While natural factors like volcanic eruptions and solar cycles have influenced climate in the past, the rapid changes observed in recent decades are primarily attributed to human actions. Let's look at closely the meaning of greenhouse gas effect. Most radiation is absorbed by the Earth's surface and warms it. Some solar radiation is reflected by the Earth and the atmosphere. Some of the infrared radiation passes through the atmosphere. Some is absorbed and re-emitted in all directions by greenhouse gas molecules. The effect of this is to warm the Earth's surface and the lower atmosphere. The effects of climate change can have significant social, economic, and environmental impacts, affecting agriculture, water resources, health, and infrastructure, especially for vulnerable populations and ecosystems. Addressing climate change involves mitigation and adaptation. Now let's talk about new topic, utilizing the ENROADS climate simulator for carbon dioxide emission estimation and achieving sustainable development goals through alternative energy solutions. Carbon dioxide emissions estimation and scenario analysis. ENROADS offers real-time simulations that demonstrate how policy decisions and technological development affect carbon dioxide emissions. A carbon taxes promoting the use of renewable energy, promoting energy efficiency, and reducing deforestation, and among the scenarios that users might assess. By varying these parameters, users can see the short-term and long-term impacts of different methods on carbon dioxide emissions. Throughout an extensive range of timescales, The tool's modeling capabilities extends from short-term adjustments to projections up to 2100. Users need to know both the immediate and long-term impacts of certain activities in order to set meaningful and achievable climate targets. For example, a user may simulate a scenario where investments shift from fossil fuels to renewable energy sources like wind, solar, and hydropower. The tool demonstrates how this change might ultimately reduce carbon dioxide emissions, assisting in maintaining global warming below the critical thresholds. EnROADS interactive feature, which provides a clear picture of how small policy changes compound and interact, shows that several reinforcing policies are needed to achieve significant emissions reductions. The ability to visualize carbon reductions is essential for stakeholders and decision makers assessing the viability of proposed climate policies. Supporting the achievement of SDGs through alternative energy solutions. One of the most beneficial parts of ENROADS is investigating alternate power sources and their ability to meet energy needs in sustainable manner. SDG 7, the meaning is affordable and clean energy, and 13, climate action, are directly aligned with this. ENROADS help users understand the effects of moving to renewable energy sources, such as wind, solar, and geothermal, and how these alternatives can reduce dependency on fossil fuels. Users can evaluate the reduction in carbon dioxide, cost savings, and job creation that might occur from larger deployment of renewable energy technology, all of which are essential for sustainable development. Additionally, EnROADS helps users to model the implementation of energy-saving efforts by promoting the use of electric vessels, enhancing industrial processes, and improving building installation. Both pollution and energy consumption are reduced by such actions. ENROADS highlights the benefits of multi-phased approach to achieving SDG targets by evaluating various policy combinations. It shows that clean energy transition plans alone are insufficient without additional policies in areas like efficiency, afforestation, and behavior modification. Fostering informed decision-making for sustainable policies. ENROADS is highly beneficial because of its system approach, which illustrates how interconnected policies affect emissions, economic growth, and energy demand. This comprehensive viewpoint ensures that legislators and business executives are aware of the whole range of consequences linked to their decisions, which encourages informed decision making. By demonstrating the trade-offs and synergies between different efforts, ENROADS encourages these 13 of balanced policies and are consistent with SDG aims. For example, the tool may demonstrate how a switch to renewable energy source could reduce emission and promote economic stability by creating jobs in clean businesses. EnROADS helps users to build routes that support sustainability and climate resilience goals by facilitating understanding of the achievement of low carbon economy. It makes the sometimes complex science of climate action accessible and useful. Therefore, EnROADS information may help create a route toward the SDGs by promoting the use of renewable energy, enhancing climate literacy, and inspiring collective action on climate change. This is another topic. Using the EnROADS climate simulator for high impact engineering research on sustainable development and emissions reduction. Using EnROADS in engineering thesis research. EnROADS can be used to produce high-quality theses by graduate students in a range of engineering fields such as energy system, mechanical, environmental, and civil engineering. This tool is highly helpful since it can model and show how engineering improvements, legislative changes, and technological advancements affect the environment. With EnROADS, students can research topics including the effects of developing sustainable infrastructure, the feasibility of renewable energy source, and lowering emissions during construction. How graduate students in engineering can use EnROADS for their thesis. Evaluating sustainable infrastructure. Civil and environmental engineering students can simulate the impact of infrastructure projects such as green buildings, sustainable transportation systems, and eco-friendly urban design on carbon dioxide emissions, energy demand, and climate resilience. Renewable energy system design. Students studying mechanical and energy engineering can use EnROADS to assess the feasibility and impacts of integrating renewable energy systems, such as wind, solar, and hydropower, into the energy grid, offering insights on energy mix scenarios and carbon reductions. Resilience to climate risks. Students can use EnROADS to model how different climate adaptation and mitigation strategies affect community resilience to climate risks, such as extreme weather events, water scarcity, and rising temperatures. Yes, this is another new topic, EnROADS and civil engineering. What is the relation in between both of them? The EnROADS climate solution simulator can be a valuable tool for civil engineers in understanding and planning for climate mitigation and adaptation strategies. Civil engineering projects are influenced by climate-related factors such as greenhouse gas emissions, extreme weather events, and resource availability. EnROADS allows civil engineers to model the impact of various policies, technologies, and strategies on these factors, helping them make informed decisions to decision sustainable, resilient infrastructure. Here is how EnROADS connects to different areas of civil engineering. The first one is energy infrastructure and emission reduction by sustainable building materials, renewable energy infrastructure. The second, transportation and sustainable mobility by public transportation impact, electric vessel infrastructure. Third one, deal with water resource and stormwater management by flooding risk and resilience planning, drought resilient infrastructure. The fourth one, urban development and green spaces by urban heat island mitigation, sustainable zoning, and land use. Fifth one, carbon sequestration projects by carbon capture and strategy, reforestation and afforestation. Sixth one, adaptation planning and resilience by extreme weather adaptation, long-term infrastructure planning. And the last one, education and stakeholder engagement by communicating impacts, collaborative planning. Now, let's come to the final part of my presentation. Together with conclusion, I'm planning to finish my presentation. This is my conclusions. The EnROADS Climate Simulator is a useful tool for graduate engineering and environmental management programs that enables students to model the impacts of specific climate and sustainability solutions. Its versatility across disciplines such as civil, environmental, mechanic, and industrial engineering allows students to model scenarios related to emission reduction, sustainable infrastructure, and renewable energy integration. By utilizing EnROADS to illustrate the long-term impacts of policy decisions on climate variables like temperature, energy use, and carbon dioxide emissions, students can better understand climate resilience and mitigation. One of EnROADS' primary benefits is alignment with the Sustainable Development Goals, SDGs, particularly SDG 7, affordable and clean energy, and 13, climate action. The platform fosters data-driven insights that can support global sustainability programs by enabling students to explore scenarios that addresses these objectives. Additionally, EnROADS promotes system thinking, which helps students comprehend the interdependencies and necessity of energy, climate, and economic policies in order to develop holistic solutions. By offering wide range of potential thesis topics, such as evaluating the effectiveness of emissions reduction measures or sustainable urban infrastructure, EnROADS provides students with the chance to conduct multidisciplinary research that bridges technical and policy-oriented perspectives. Additionally, its strong quantitative abilities enable the production of outstanding data-driven thesis work that supports threshold, fact-based conclusions, and useful recommendations. All things considered, EnROADS equips students to conduct important research that not only broadens scholarly knowledge, but also makes a sustainable contribution to sustainable development goals and actual climate action. Thank you so much for your attention and participation. Now, Mr. Farhad Bolouri will continue. Thank you again.
Hello everyone, good morning and thank you so much Professor Dr. Hüseyin Gökçekuş for their valuable presentation. Now I want to share with you the practice part of the EnROADS and how we can see these ones in the platform of the EnROADS. 1 minute, just I can share my screen. It is shared. I can start, but I think not yet. Yes. When you search EnROADS in the Google, you will it will be open for you. I show here. Yes, with clicking in this one, explore the EnROADS. Yes, you will have this environment. Here you have about 20 languages for using. If you are Arabic or Turkish or any other language, you can use in your own language to understand it better. And also for more information about the environment, you can see our first workshop. But today for working with this environment, I start from the beginning. In the simulation part, you have the reset policies, reset assumptions, reset policies and assumption. Policies we set to these ones. We have around 18, and we can do what we want to do and what we experience from the papers and we have in our own lives. We can see how it affects the temperature of the world or the global temperature and the other things. But when we want to reset it and start from the beginning, we can use from this one, reset the policies. Also, we have the assumptions. When we do something with the assumptions, I will show you what is the assumptions. When we go through, I will show you. And from here we can reset the assumption, and from here we can go to the first section because we reset all of the policies and assumptions. Here we have the graphs. There are so many graphs. We will discuss them. For example, we have air pollution graphs. We have and this one's just the graphs of the impacts. For example, sea level rise in the world. The other things. Also in the graphs we have the greenhouse gases emissions that Professor mentioned, CO2 emissions. Because of the importance of the CO2, it is in a different part. Also about the energies we have in the mechanical engineering you can use in your papers, land and agriculture. Also we have the population, GDPs and the other detailed information. Also in the view one, we have the main graphs, that it is 2 graphs, but not 2 as I showed. We have more than 100 graphs. Also we have the Kaya graphs. It mentioned to population, GDP and energy and CO2 emissions. Also we have the minimized graphs here. We can choose which one we need. We can choose it and see it here. And how our policies can take action and effect on it. And you can see how it changed with these ones. Also, we have here the actions and outcomes. When you click, it shows which policies you did and what is the outcomes and the effects of it. And for example, world temperature, CO2, sea level rise, which graphs you choose. Until now, it shows the outcomes and the effects on them. Also, from here, we have the units. We always using metric, but you can use the US units too. Also plate sound, and these are not important. Also, we have in the help one. The first one is very helpful for you. If you click on it, a window like this will open for you. And from here, you can get so many information about the model. For example, when you click on the call or any other, it shows you what they mean with the one word that it called. Also, what is the examples for it? What is the big message about it? Key dynamics. Also here, I must mention, this model is a system dynamics model, which is a tool for system thinking. 14,000 formulas is behind this model. So here they introduce you the key dynamics. Also here you have the potential co-benefits, equality consideration, also videos and the other information about that part and policy you have here. For example, for civil engineering, which one is more important for us? The coal, oil, natural gases, and also we have, for example, building and industry energy efficiency. When you click, it said to you what it means, what is the examples, big message, key dynamics, as always for the other ones. Also, we have, for example, transportation, energy efficiency. It said to you, for example, it here said increase or decrease the energy efficiency of vehicles, shipping, air travel, and transportation system. It is not only for the cars. And it said, for example, energy efficiency includes things like hybrid cars, expanded public transport, and the other things that it can affect the energy decreasing or increasing. So I come here again. Up here, we have this one. When we do that, it is like the reset all of the policies. This one reset the graphs for the first one. These two graphs that they do it for the beginning graphs. Up here, you can use it for the last actions that you did. Also, when you do something and you want to see just the last one that you did, how does it affect? You can use this one, replying the last change, and you can see how is it changing. Also, from here, you can take it as a full screen for working on it. From here, you have the minimized graphs. But I took this one. Also for each graph, when you come to here, the three dots, if you click here, it shows you the description of that one. For example, greenhouse net emission. It shows you what is the calibration they did for this simulation and what is the information. For example, they used IPCC AR6 2021 information for modeling and the other information. Also, from here, you can hide it. You can show, for example, where we are here nowadays and how is it going with the modeling. Also, you can use this one to make it larger to showing and presentations. We have it in a new window. And also in the EnROADS, when you are doing some modeling, for example, we did here some policies, and we have this graph. When we want to present this graph in our presentation, or especially in your thesis or papers, you can copy the data and open the Excel file and paste in your Excel file and make your own graph from here. For example, we had here this one. So I want to make it for myself. For example, I use this one. Yes, it shows like this. Of course, you must make the change that you want for, or also this one. This shows like that for your own, and here you can make your change. So the data are available for copy paste in your Excel file and Word files and your thesis and papers. Now I reset all of them. Also about the assumptions, first before starting the modeling, I want to show assumptions. Some assumptions you have here for each of these policies. You can do some change some assumptions by clicking these three dots. For example, I say when I do a policy for coal, it not start directly from 2025. It make a delay and it start with 2050. And I change, and now when I change here the coal, as you see, it start from 2050 to make an effect on my, for example, greenhouse gas net emission. Because until 2050, I said my policy cannot work in the reality. Here we can do something with policies, but for the bigger assumptions, we must to go to here. For example, for each one we can do some change. For example, for air pollution from energy, we have these ones. For example, for coal, the air pollution is 0.12 megatons per energy. I say no, this is not 12. I read in one paper it is 15%, so I can make this assumption. Or for example, gas, I say no, this is not true. I make it 20. And yes, this is out of the range. The maximum can be 15. So I do it with 15. So you can do this change, and when you do, as you see with the blue color, it shows that you do some change in the assumption to just announce you that you made some change in the model assumptions. Now we can go to restart to all of them, and yes, do this from the first step, and also I don't want this one, yes. And from here we can do firstly, I want to choose the energy supply policies. For example, I say we can reduce the coal. Also, we can do something with the renewable energies. We can reduce oil. Also, we can use some nuclears, natural gas. We can reduce net zero carbon policies. We can do. Also, carbon price we will increase. Bioenergy we will use. Also in the transportation part, I say, okay, we will do better and we will increase our energy efficiency. Also, we will use, for example, hybrid cars, and we will increase our electrification transportation. The same I do for the building and industry, and you can see how is it affect on the greenhouse gas emissions. Population and GDP, both of them, when they increase your temperature. Also about the natural-based ones, I say, yes, we can do better things. And also in the agricultural part, for example, this one includes the methanes that comes from our agriculture and food habitats. And I say, yes, we can do some good policies here too. About the waste, we can do better policies, and for deforestation, we can do. And with these policies, you can see we can reduce it from 3 degrees Celsius to 1.7. And also from here, I want to show the graph of impact. For example, temperature change. Yes, this one, what United Nations ask us with 2100. They ask us between 1.5 and 2. But if the world remains that it goes now, it goes to 3.27. But with these policies that we make the change here, as you see, it came to 1.67. So it is good. And what is the United Nations ask us, and IPCC and the other groups, they want us to be here. And also here, the impact figures are very good because, for example, air pollution from energy. All of these ones are related with engineering students and civil engineering. For example, air pollution, as you see, if it goes like now is going, it goes to 26.25 megatons, PM 2.5 per year. But from today, if we do this change, it goes to 4.34. Also, I want to show you the change of the sea level rise. Yes, this is the sea level rise that we have and that we will have. This is 67 centimeter, but now with these policies, it will be around half of meter. Also, one of the impacts that we have, I want to show is the graphs impact, sea level rise, ocean acidification. Also, I want the lands that are in danger. Yes, these are the marine animals and the land animals that they are in the risk. Also, there's a good graph that shows with 2100 which lands can go to, yes, the risk of the floods. You can use all of these graphs in your, for example, papers and thesis. Yes. Here it shows with 2100 which cities will go under the sea if the world goes with this direction. For example, for Cyprus, I'm searching. We can use it larger. Yes. As you see, in the northern Cyprus, we don't have any area in the danger. It is for 2100. But in the southern part, as you see, this part is in danger. For example, Limassol Salt Lake is in danger with 2100 if we don't do anything. This part can be go through the under the water. Also,
sea level rise.
Yes. Also, if we do this for long term, the story will be changed. Now I show you. In this one, some other parts are in danger too. Also in the northern part. Yes. If we do it for long term, yes. In Gazi Mausa, Corfez, we have endangered these parts. Also, the part of here. Güzel yurt. Yes. Güzel yurt. Yes. When you have in touch with the seas and you don't have any rocks and the other things, with the long term, the sea level rise can make a danger for your land too. Yes, for example, this one added recently in last 6 months to this model. And you can use this map for your own country. For example, we can see which parts in Turkey are in danger too. You can see. These are the just the impact figures. Also, as I showed you, so many impacts you have. For example, CO2 concentration, you see, is very important for us in our papers. Also, I show the air pollution for you, sea level rise, and the others. For example, for biology students, the ecosystems and everything can be shown. For example, with this baseline, if we go, it goes to danger part. But if we do these policies, as you see, it goes to better situation and it goes like what we are nowadays. So now I want to show you this triple or these three dots. From here, you have so many information here too. For example, as I showed you, you say I'm doing this policy, but it will show with it will be start, for example, with 2050. For the other things, you can do the same too. For example, reduce new coal infrastructure. You say I can do with 30%, for example. Or the year to reduce new coal infrastructure, you say we couldn't do from today or tomorrow. So we will do it with, for example, 2040. And the other things. Also in the graph part, you have the related graphs here too. For example, the coal primary demand and the other things, and you can change. Also from here, as I showed you in the guide part, from this one you can see the examples, big message and key dynamics from here too. And from here you can see the graphs about it. As I showed you also, when you come to here, in some graphs, you can see some more details. Also, I can use this one. Yes, for example, for this one. If we don't do anything here, you can see how is the methane change. Also, I choose this one and this. Yes, for example, for CH4, you see we did everything in the civil engineering part and also in the energy engineering part. We did so many policies, but as you see, for the methane or CH4, you can see there's no any change. I'll show you the larger, as you see. Because these things and these policies that we did, all of them are affecting on the CO2 emission. But what we can do for the methane or CH4 is the agriculture part, because as I said, and if you see here, the methane just arises by the cows and the meats that we are using. So we must know the policies that we are doing is affecting directly which one. For example, here, as I mentioned, for CH4 or methane, there's no any change. But now, if I do this policy, as you see, it changed directly. You see, because methane is directly it depends on the agriculture emissions. And also for changing these things in your papers, here I just show you how you can change them. But for changing, if you are using this model in your papers, for each of these changes, you must read some papers, theses, and you must introduce in your paper when you change it. For example, for the renewables, the tax from 0 to, for example, I say, yes, 0.05, you must say, because in this paper they mentioned that we can do this, or in this report, United Nations reports, the paper, valuable papers, and also the thesis. Just these ones you can choose and see and use their data in your modeling and policies. Also here, as Professor mentioned, I want to show you what we can do for civil engineering. As I showed you, the low carbons and renewable building materials we have, for example, in this one, we have the buildings and industry. And for energy efficiency, we can do, and also we can do something for electrification. As you see here, we have so many things about the electrification in industry and building. Also, we can go to renewable energy part. It means this part. For example, for transportation, we can increase our electrification and energy efficiency. Also, in the energy own, we can reduce the coal usage, oil, or we can use more renewable energy. Also, in the transportation and sustainable mobility that Professor mentioned, we can use the transit systems and infrastructure of sustainable urban mobility that I showed here. Also, about the electric vehicles infrastructure, we can use the electric vehicles or EVs. All of them are here and it introduced here, and also we can see, for example, final energy consumption, how does it change with this policy and using excuse me, the energy efficiency of new transport policies, and which year you start is very important. As you see, if you start it from now or 2025, it affects like this. Or if you make a delay and start it with 2075, it is actions like this, and it is not good for you. Also, about the other parts for water resources and storm water management. As you know, and as I showed you before, in the graphs you can see the sea level rise, and we saw the map of the areas that are in danger in long term, and the other things, for example, lose the life in the ocean. For example, marine animals, you can see they are in danger, and with our actions they are in worse one. Also about the drought resilience infrastructures, we can see the graphs and how is it going. From the impact one, we can see them. Also from these ones, for example, from greenhouse gas emissions, from CO2 emissions, we can see and how is it changing. About the urban development and green spaces, we have the same carbon sequestration projects we have, and but I want to come to education and the stakeholder engagement. As Professor mentioned, communicating impacts and collective planning. I want to talk about it. This is what we are doing today. We are discussing the model. We are introducing, for example, for you, you are doing your own model and discussing with us. These are all of them about the education and awareness. And also, as I said, when you do these things and just when you copy your modeling, you can easily paste in your paper when you wrote something. You can just paste the link as your reference. And each one and anybody just with copy pasting it or clicking in, on your paper, it comes directly to your model. Yes, as you see, it shows all of the change that you made, so they can control your model and what you did. You introduce in your paper, but with copy pasting the link, directly people can see your modeling in the system. Also from here, I want to show if any other figures. Yes, these ones, the last one, is the historical data of the this model. They show you, for example, this one. As you see, they did this one from 1990 to 2020. So it is for 31 years, they collaborate the model. And as you see, it is very good and cover it, so we can trust on the model. Also, I want to show another one. For example, primary energy. Yes, this one is important for us. For example, wind and solar energy. They used IEA. Also, the EnROADS model, you can see it covers. Also for solar too, they did the model. I showed this one in the larger mode. Yes, as you see in wind and solar, exactly the EnROADS can model it and cover it.
Same character.
Yes, for 30 years so you can trust the modeling for the future. These are for just calibration and showing the how much you can trust on this modeling. In financial, we have so many, for example, marketing of the oil in the world and the other things. I don't focus in these parts because these ones are financial, or this one is about the population and GDP. I'm focusing on these parts because these are the engineering based ones. Here we have the primary energy demands. Here we have the primary energy demands by the types. The total ones shows better ones for us. For example, the policies that I did, as you see, have the effect our global source of primary energy that we are using. For example, we reduced the coal, also oil. Also, we used more renewable energy that you can show in these figures. And as I said, you can copy the data, or from here you can make the screenshot and copy and paste in your papers. Also about the graphs, I want to reset all of this and show you another thing. View the graph. For example, from here, I want to show something about the ocean acidification, or another one we can choose, ecosystem, or lose in the ocean. Yes. Here we have this one. I want to just show what we can action in our part can affect in the other parts too. For example, in transportation, when we increase our energy efficiency, electrification, and also in the building, I'm choosing this one because these are directly related on civil engineering. So I'm getting better my energy efficiency in building and industry, also electrification. As you see, we did something our transport and building, or in one word, civil engineering. But you can see how is it affect the marine animal, for example, and the other ones. It shows that what we are doing on our field can affect in the other fields too. Yes, these are the things that we have about this one. Also, source and area. We have about the air pollution that you can use in your papers. These are the effect ones. CO2 emissions. Yes, this one just you shows you the CO2 emissions from the energy by sources. And for each one, you can use the many graphs that you have here. As I said, more than 100, maybe 150, you have the graphs, and you can control all of them by doing the change and see what affect your policies in the real world. Yes, this one's, and from the minimized graphs, if there's any important things that I must mention to you. Yes, this one is important too. When you are doing your policies, greenhouse gas net emission, you must control this one always for yourself too. Yes, this one. And this one is the temperature change that I mentioned in the beginning. So I want to finish my part in this here. Just please practice these parts in your laptops and with yourself, and the policies that I said. In the first time, you can change with your own opinions, but in the next step, if you want to use this model in your presentations and papers, you must change these policies, but the range that you are getting from the papers and reports. Thank you so much for your attention. I also thank Professor Dr. Hüseyin Gökçekuş nearest university and all of the participations that came to here, and also participate in our workshop online. Thank you so much, and see you in our next events. Thank you so much.
Hayat hızla akıyor ve biz bu hızı seviyoruz. Her güne heyecanla başlıyor, her anı doya doya yaşıyoruz. İlk günkü heyecanımızla yılları aşıyoruz. Zaman akarken biz de kendimizi arıyoruz. Heyecanla, merakla. Sen de kendini mi arıyorsun? O zaman zamana yetiş. Bu sadece kendini bulmakla ilgili değil. Asıl heyecan kendini yaratmakta. Bir şeyler mi yaratmak istiyorsun? Mükemmel. Metali işlemeyi, bir bina yapmayı, bir iş kurmayı, hatta bir şehir kurmayı öğren. Hayat kurtarmak, teknoloji geliştirmek, üretmek. Hepsi burada. Ve burada tüm deneyimler profesyonellerle yan yana. Ancak hızlı ilerlemeliyiz. Çünkü bugün şimdi gerçekleşiyor ve yarın çok yakın. Hayatta öne geçmek istiyorsan önce zamanın önüne geçeceksin. Hep ileri gideceksin. Bu Doktor Suat İrfan Günsel. Tanıyor musun? Onun da söylediği gibi. Üniversiteler toplumların dokuma tezgahıdır. Toplumları geliştirir, dönüştürür ve gelişmesini sağlar. O burayı bugünden yarına hazırlamak için kurdu. Senin için, ileriye gitmek için. Yana ya da geriye değil. Sadece ileri. Çünkü gelecek çok yakın. Hadi harekete geç. Fikirlerin ne kadar ileride olursa yarına o kadar yaklaşırsın. Yanındakileri de geleceğe taşırsın. Bu senin geleceğin, senin fırsatın şimdi. Hadi yarın yakın. Hepimizi ileriye götür.